Hello my friends and welcome. I recently found out that there are these small wine chillers or bottle coolers that can cool a bottle of wine or other beverage faster than a simple refrigerator and more conveniently because you can place it on the table to keep your bottle cold. But these bottle coolers are pretty expensive. Some of them cost more than $100. So can I build one much cheaper and almost as good? Let's find out. Spoiler alert, this DIY bottle cooler turned out to be pretty good, but first let me show you how I built it. To keep the cost down, for this project I will use household materials. For example, the box will be made from pieces of laminated floorboards and some 3mm laminated MDF panels left over from a piece of furniture. I will cut the MDF and aluminum panels with an electric jigsaw, and because MDF makes a lot of dust, I will go outside to cut them, and I also need protective goggles and a dust mask. After cutting all the panels, I will use some sandpaper to make the edges smoother. Next I will mark all the holes and cutouts. The thicker 8mm panels will make the stronger part of the structure that holds the heavy radiators. And the side panels will be made from the thinner 3mm MDF. To make the cutouts, first I will drill some holes, then I can use the electric jigsaw with a thinner wood blade. For the big round holes I plan to use a hole saw cutter with the 80mm blade. But we have a problem, the laminated part is very strong and cannot be cut with this cheap tool. So I will go back to basics with the electric jigsaw. I cut these holes very slowly and they came out pretty round. The MDF panels are finished and ready for the next step. I designed this cooler box to sit at an angle, similar to the original ones. It's a bit more complicated this way, so I'll check the components. Everything fits so far, now I can make all the pilot holes, and I will mount the panels with a few screws. The side panels will be mounted with the laminated part inside, so they will be protected from the possible humidity. The rudimentary MDF box is finished. Now I can dismantle it because we still have a lot of work ahead of us. I will use this chamfering bit to countersink all the screws. This aluminum plate will be used to make a cooler box inside the cooler box. It has a thickness of 1.5mm. It's not very thick, but it's a leftover piece from my DIY mini fridge from a few years ago. It's already paid for, so I will use it in this project to keep the costs down. I want to make a rectangular aluminum box with a width of 85mm. The MDF case is 95mm wide, so there will also be some space for insulation. For the aluminum plates, I will use the electric jigsaw with a metal cutting blade. The main plate is cut, it will sit on the cold side of the peltier modules, so I will mark and drill 8 holes to fix it to the MDF board. The holes will be smoothed out with fine sandpaper and I will countersink these screws as well. I want to bend the aluminum plate, which will be very difficult. To make it easier, I will scratch all the markings on both sides. And I will also heat up the aluminum so that it will be easier to bend. But without the proper tools and using only my hands, it turns out to be very difficult to bend this thin aluminum plate. The challenge is to bend it only on the markings and not to deform the rest of the surface, because it needs to make a good contact with the peltier modules. So I had to improvise and use wood boards, different pliers and clamps, and a lot of muscles. And after only 3 hours, I finished the aluminum box. It's not perfect, but it will do the job. The middle MDF board is 8mm thick, and peltier modules are only 4mm thick. So I will make some aluminum spacers from this 5mm plate. They have a pretty rough surface after cutting, so I will use fine sandpaper to make them smoother. Much better now. These tiny scratches you see are magnified by the light and camera, but in reality the surface is very smooth. I will use this milling bit to make 2 grooves on the middle board for each peltier module. This is where the wires will hide, under the heatsink. The wire grooves are finished. We have some more work to do on this board. To cool down the peltier modules, I will install these two old AMD CPU coolers. I will fix them on the board with 3mm screws, so I made some markings and drilled 2 holes for each heatsink. This small zip tie will be used to hold the screw tips near the heatsink, because when I tighten the nuts, it may push the screws away from the heatsink. Now I'm going to add a washer and a nut on each screw. The zip tie only holds the screws together. The heatsink is tightened by the screws and nuts. The aluminum box will be mounted with small screws on the other side of the board. So earlier I marked the middle board before bending the aluminum plate, and I drilled some tiny holes. I like these 12703 peltier modules because they use less power than the other ones and still have good results. 03 means that they work with maximum 3 amps, so I can use 2 of them without stressing the power supply too much. For a better temperature transfer, I will add thermal paste on all contact surfaces. The hot side of the peltier module will make direct contact with the heatsink, because it's important to cool down the module as much as possible. So the 5mm aluminum spacers will sit on the cold side. The aluminum spacers stick out 1mm from the board. This is good because I don't want the cold aluminum box to touch the middle board. So I will add a few strips of 1mm sticky foam. I will also cover the hot screws coming from the heatsinks to insulate them. I tried to keep the main aluminum panel that makes contact with the spacers as straight as possible. But let's be honest, after all that bending, it's not perfectly straight anymore. So to compensate, I will add more thermal paste than usual to cover all those imperfections. Don't worry about the excess paste, it will be pushed to the side after I tighten all the screws. What about those small screws? How can I tighten them inside this box? With a regular screwdriver it's pretty difficult. So I got this flexible extension for my screwdriver. Oh yeah, much better now. The internal part of this project is finished. Now I have to build everything around it. I will cover the rest of the panels with vinyl. I think the final product will look better in matte black. But in some cases the vinyl will also protect the MDF panels from any condensation, because it also covers the edges of the panels. Cutting the round parts is a bit tedious, you just need a small cutter and a lot of patience. It took me another hour, but I finished covering all the panels. This is the bottom panel under the cold aluminum box. The laminated surfaces are already protected from moisture. I will also cover the exposed MDF on the edges with electrical tape to protect them. It's time for some thermal insulation. It will keep the aluminum box colder and it will protect the panels even better from moisture. So I will cut some pieces from this 2.5mm thick extruded polystyrene sheet, which is also left over from the laminate flooring. You may think that the 2.5mm insulation is not thick enough, but remember that this is not a sealed enclosure. There is a big hole at the top. This insulation is necessary so that the cold aluminum radiator does not directly touch the MDF panels. The insulation will be fixed to the panels with double-sided sticky tape. The CPU coolers also need some fans. They will be mounted to the radiators with simple screws. We have 3 pairs of wires, 2 from the peltier modules and 1 pair from both cooling fans. I will use a small piece of heat shrink tube to hold the wires together. And all the wires will go through this hole in the back, so let's arrange them a bit. The wires will be connected in parallel using this terminal block connector, and I will power everything using thick 2.5mm square wires to carry all that current. This can be the front panel depending on how you want to place the bottle cooler. It needs 2 protective grills for the cooling fans. I salvaged them from old PC power supplies. This is the last panel. It will take only a few more screws to finish this project. And it is finished. What do you think? It's just a wooden box, right? It needs a 12 volts and 6 amps power supply. You can use an old PC power supply, like I did with my Peltier cooler box. It cost me nothing because I'm a hoarder and I have a lot of old PC components. I will use this one because it has a volt ammeter display. But is the top hole the right size? Let's check with this bottle of fine grape juice. It fits nicely. For the first test, let's measure the temperature of the cold radiator. I will place the thermometer probe between the two Peltier modules. The room temperature is 23 degrees Celsius. And here we go. Let's turn on the power supply. To show you how fast the temperature is dropping on the cold radiator, I will use this boring clock and I will fast forward the video. You can see that the temperature is dropping pretty fast. After 14 minutes, it's down to 0 degrees Celsius and continues to decrease. And we have ice on the cold radiator. I thought I had deformed the aluminum plate, but it looks like it still makes good contact with the spacers and Peltier modules. The maximum current consumption is 5.8 amps and in time it drops to 5.3 amps. From this, the fans draw 130 milliamps. The rest is used by the Peltier modules, so less than 3 amps for each module. But the real question is, how fast can it cool a bottle of water? I'll insert the thermometer probe into the bottle so we can measure the temperature of the water in real time. I've reset the time to 12 o'clock, so it will be easier to check the time. You can see the temperature dropping from the first minute. After 23 minutes, the bottle temperature is 15 degrees Celsius. I checked the coolers and they are just a bit warm, that's fine. 12 degrees is reached after 43 minutes. This waiting may seem long, but that's enough time for you to cook a delicious meal for your partner. And if you want your beverage to be even colder, it will take only 65 minutes to get it down to 10 degrees Celsius. So you need to schedule the spontaneous romantic evening if you use this type of wine chiller. If some of you actually bought a real wine chiller, please leave a comment below and let us know how fast it cools a bottle of wine. But no worries, you can use this bottle cooler for any type of beverage. For the real men we have beer, that's nice. You can also use it with smaller bottles, which will cool down faster. I want to thank all my patrons for their support. If you want to see these videos a few days earlier and more DIY videos, please check out my Patreon page. After all this work, now it's time for a real romantic evening. And the bottle will be put back in the chiller. But there is one downside if you place this bottle cooler on the dinner table. Can you guess what it is?
Draga mea, mă bucur că în seara asta ești alături de mine și de acest minunat răcitor de sticle de vin făcut dintr-o sursă ieftină.
Yes, the cooling fans are not very romantic. The cost of this project for me was close to zero, because I salvaged the CPU coolers and power supply from very old computers. The leftover panels, I was about to throw them away, and I reused the Peltier modules from other projects. There is some room for improvement. Instead of bending and deforming the aluminum plate, it's better to cut it and mount the pieces together like I did in my mini fridge project. It will make better contact with the aluminum spacers, and it needs insulation between the cold radiator and the middle panel, at least 2.5 mm. This way the aluminum box will be even cooler. So this is my simple or not so simple bottle cooler. If you enjoyed this video, please share it, leave a comment below, and I'll see you soon. Bye!